Okay, so section B questions. Now remember, each of these questions you need to start on a new sheet of paper. I didn't take a look at any working that you did on the actual exam paper, just everything that was on binder paper. The examiner is going to do exactly the same thing. So I'm going to try and squidge it on this page though, rather than having to keep scrolling up and down. Let's see what I can do. So the first two terms of an infinite geometric sequence. So the key here is it's a geometric sequence, which we know means that there's going to be a common ratio somewhere. So R represents a common ratio. We know that a geometric sequence is formed by multiplying one term by another. So to find the common ratio, we're going to do log base 2 of x divided by 2 log base 2 of x. It's basically u2 over u1, the second term divided by first, and we can see that the log base 2 of x is common to both top and bottom, so it can cancel out, and we get r is 1/2. So that the sum of the infinite sequence is 4 log 2x. Okay, so let's find here we go, the sum of an infinite geometric sequence. Is that what they've asked us for? Yep, the sum of the infinite geometric sequence. So we're using this formula here. Let me okay, so u1 in our case is 2 log 2x. So that's 2 log base 2 of x over 1 minus 1/2. So 2 log base 2 of x divided by 1/2. 2 divided by half is 4. Okay, so far so good. So the first three terms of an arithmetic sequence. So now we've got an arithmetic sequence, so we know that we've now adding values to get to the next term. So we need to find D, and we need to give our answer as an integer. I think I'm going to have to go down here to start working here on this one. So C. So to find D, we know it's U2 subtract U1 or U3 subtract U2. So we've got, oh gosh, that's quite an exercise. So we've got log base 2 of x over 2 subtract log base 2 of x. We know laws of logs means that because we have the same base and we're subtracting them, we would divide the terms. Let me just remind you here. So here, if we've got log of the same base and we're subtracting, we would divide the a and b. So we've got log base 2 of x over 2 divided by x. So that's log base 2 of, okay, let me show the working, x over 2 multiplied by 1 over x, which is log base 2 of, 1/2, because the x's cancel. Log base 2 of 1/2 is log base 2 of 2 to the minus 1. The negative 1 goes in front, and we know that that's equal to 1, so it's just negative 1. Okay. So the next one is we need to show, S12 is the sum of the first 12 terms of the arithmetic sequence. So we're going to, again, go back to our formula, so the sum of the arithmetic sequence. So I'm going to use this. 12 is 12 over 2 brackets 2 lots of, what do you want? Log base 2 of x plus 11. I did the 12 minus 1 in my head, times negative 1. So 6 brackets 2 log base 2 of x, and plus 11 multiplied by negative 1 is minus 11. And what do we have to show? Okay, so they've expanded that out, which gives 12 log base 2 of x minus 66, which is what they had here. And finally, part E, given that S12 is equal to half the sum of the infinite geometric sequence, find x, giving your answer in the form 2 to the power p. So S12, so that's this expression here, is equal to half the sum of the infinite geometric sequence. So the sum of the infinite geometric sequence was this, and it's equal to half of that. So it's only going to be 2 log base 2 of x. So we would write 12 log base 2x minus 66 equals 2 log base 2 of x. But let us... Okay, so I'm going to rearrange this. So I've got 12 log base 2 of x minus 2 log base 2 of x equals 66. I'll just rearrange that. So if I've got 12 of them minus 2 of them, it gives me 10 log base 2 of x equals 66. So log base 2 of x equals 6.6. And then using our this format, this rule here, changing from base to power form. Okay, so I have this format, and I want this format. So my base is a, so this is 2 to the power 6.6 equals x. So x is equal to 2 to the power 6.6. And that's in the format of 2 to the power something where p is a quotient. So in other words, it's a number. It doesn't have to be a whole number.